Hello everyone. I would like to welcome you all to today's session. I would be solving today's problem and continue the daily Leet Code challenge streak. So today's question is reordered list. It's a medium level question in Leet Code. Though its solution is little bit easy, but the implementation is quite tough. So the question statement is we are given the head of the linked list and we have to reorder it somehow that it looks like this. It's somehow a ordering which the first element is the first from the starting, the second one is the first from the last, the third one is second one from the starting, and further you can see the diagram given here. So our intuition to solve this problem is it involves ordering. Like first we have to calculate the last one, so we have to think of a data structure that involves ordering both from first come first and first come last. So we can use stack and queue to solve this problem. We have to use one stack and one queue. First I need to find the mid value of this linked list, which we definitely can solve through two pointer approach, the one which increases with 2 and the slow one which increases with 1. So let me write. Find the mid value. We need two pointers. Let's name it fast and slow. Both would be pointing head at first. Okay, definitely the first one to reach the null pointer would be the fast, because we would be incrementing it by 2, and the slow one would be 1. So let's put the condition that fast should not be equal to null pointer, and okay, as we can see the pattern that it involves the incrementing from the first index. So we need to put the first 0th index, then the first index, then the second index. So the data structure that involves first come first out would definitely be the choice. So we can use a queue here to store the values from the starting. Definitely the position that would we be storing would be of slow, and we should not store the first index 1. We should store from the second one. So let's put slow should be slow next pointer, and then we can definitely push it the val of index here. Further incrementing the fast one first, so fast would be equal to fast next. Okay, here is a catch, like what if the first gets a null pointer here? Definitely we have to break it, so we have to put the condition like if it is equal to null, we have to break it. Cool. Okay, so up till mid we have got the values in order in the queue. After that we have to store something like the first index to be stored would be the nth, then the n minus 1, like it should involve in the reverse order. So the data structure would be definitely be first come last out from the mid to the last index. So we would be using a stack. So let's create a stack here, and while the slow definitely don't get to the null pointer, we would be increasing it. Okay, se dot push the value of the index, and we would increment it by okay. Okay, in both the data structures we have got our values, like in the queue and the stack. Then just we have to alternately put the values, changing the next pointer of each indexes. So while we don't finish up all our structures. Okay, sorry for the screen issue. Okay, so we got our both data structures ready. Queue stores up to mid value and stack stores from mid to last value. So we will store while both of them do not get finished. Then what if our head, okay, we are going to change our head pointer. So uh, what if it gets a null pointer? So we would definitely be breaking it. Okay, the first one to be stored from would be definitely from the queue, as it is in the increasing order. So head value would be equal to uh, q dot okay, stack top. Okay, the first one would be here in the example, the first one would be 4 that comes from the stack. So we have filled it. Then we are going to change the index, change the next pointer of this index to the first one from the queue. So head value would be equal to q dot front. Likewise, we have to pop it. Head would be equal to head. Okay, what if we get a null pointer here, or we would be breaking it out? Okay, so the first one that head points was 1, but we did not need to change the value of 1, so we would increase it by 1. Okay, okay, so we are done with our code. Let's run it. This is showing a wrong answer, getting a 4 again here. Okay, we didn't increase it the second time. Okay, we have get a AC here. I'm also submitting it the first time. Let's submit it. Okay, so this was the solution of this problem, and